In this question, we have two frictionless trolleys which move along the same straight line towards one another. The masses and velocities before the collision are shown. So when you see a question like this, your first instinct should be to calculate the total momentum. And the total momentum is going to be none other than m1 u1 plus m2 u2. Now I'm going to treat m1's velocity as the positive direction. So we have 5 times 4 plus 2 times minus 3, since m2 is moving towards the left. And this gives me a value of 14 Newton seconds. Now, we already know that because of Newton's third law, for an isolated system, the total momentum is always conserved. And so, our momentum before and after the collision should always be 14 Newton seconds. The question then goes on to tell us that the trolleys collide and stick together, and they ask us what is the magnitude of the total momentum at the instant of collision and what is the final velocity of the trolleys. So, the total momentum, as mentioned, since it is always conserved, is going to be 14. So the answer is either C or D. However, the final velocity we need to calculate. We know that momentum is conserved, and therefore the final momentum is also going to be positive 14 Newton seconds. Now, however, since both objects are stuck together, it's a completely inelastic collision. And so, finally, we have m1 plus m2, since they are stuck together in one gigantic body, times v, because they move off with a common velocity, which is equal to 14, which is our final momentum at the end of the day. So this gives us 2 meters per second towards the right, and our answer is C.